This is our video for section 10.1. We've done some notes in class already, and what we're basically going to do is we're going to go into kind of a formal understanding of a confidence interval, what it means, what we have to remember to check, and all the things that go into constructing a confidence interval for a mean. And we've been kind of discussing these informally, but now we're just going to make it a little bit more formal. We're starting here with conditions for inference. And we have a saying here in AP Status says, it's a sin to forget our conditions, SIN, standing for different parts of our conditions that we need to be aware of. The first condition, starting with an S, is that the data must come from an SRS. Because if it's not coming from an SRS, then we don't know if the sample is representative of the population. That's the most important condition, always the most important condition. The I stands for independent, meaning that the sample data must be independent. And the way that we check for that might look familiar to you, especially if you just took the Chapter 9 take-home test. It says big N is at least 10N, meaning the population is at least 10 times the sample size, and that allows us to use our standard deviation formulas for sample means and sample proportions as we discussed back in Chapter 9. So both of those things need to be checked in addition to checking whether the sample data comes from a normal distribution. Now, that can happen a couple of different ways. If you have sample means, then if the sample is at least 30, then by the central limit theorem, we're going to be approximately normal. Or the population could be normal. Those would both allow us to use the normal approximation for sample means. And if neither one of those two are met, then we have some other strategies which we'll get to in just a little bit. However, we also should be aware of the normality check for proportions, again, which we've seen before. N times p is at least 10, and n times 1 minus p is at least 10. And each one of these needs to be formally written out when we're doing any kind of inference, including confidence intervals that we're working on now. If any of them are not met, then for our purposes, we're going to proceed going through with the confidence interval or the significance test. We'll just say we are proceeding with caution. Now, yesterday in class we were talking about constructing 95% and 99.7% confidence intervals because those were nice and easy. Those were when z star equaled 2 or z star equaled 3. But what we're going to talk about today is we don't have to limit ourselves to just those two confidence levels. In fact, we can find any level of confidence we want. All we need to do is know how to find the z star, or the critical value, as it's also called. And with a basic understanding of the z-table, we'll be able to figure that out pretty easily. Basically, just keep in mind that the z star is the number of standard deviations away. Z star is the number of standard deviations away from the mean. So, let's look at constructing an 80% confidence level. So we want to catch the central 80%, and that's the key part there, the central 80%. And in doing so, that means you have 20% left over, because 80 and 20 make 100. But realistically, we want to be focusing more on what's going on in the tail, because that leaves 10% in each tail. Now, if we look over here at the normal curve, we can get a better sense as to what's going on. Here, your central probability, there's your mean right there in the middle. You want to go 80%, you want to get 80% in the middle. So that means you're going 40% above and 40% below. Now, the z star exists right here on the upper limit of that central probability. And so if you're looking for where that value exists, well, you're looking for what area is to the left of that point. And the area to the left of that point, well, there's 0.8 in the middle, but you also have 10% in the left tail. So when you go to your z-table, what you're actually looking for is the area that has 0.9 to the left. So if you think about what we're doing here is kind of like a working backwards problem when we were dealing with chapter 2 and the normal distribution, finding the probabilities. We're looking for the z star that corresponds to the 90th percentile. So this is the z star for the 90th percentile. And it's kind of confusing because, again, we're looking for the 80% confidence level, but the value that we're actually looking for on the table is the 90th percentile. Again, 80% in the middle, 10% in the left tail. And when you do that, you end up getting that z star is 1.28. And therefore, you can go ahead and construct that confidence interval by taking your mean, which whatever it might be, plus or minus your critical value, your z star, times whatever the standard deviation might be. And that allows you to construct that confidence interval for an 80% confidence level. Okay? Now you'll notice our z star is 1.28. Yesterday we were focusing on when it was 2 or 3. Well, now it's a decimal. Now 80% confidence is okay, and sometimes you'll be okay with being wrong 20% of the time. But generally speaking, we want to be a little bit more accurate than that. So let's look at a couple of other ones. Let's start here with C equaling 0.85. Now when I say C, that's the confidence level. And when it says 0.85, obviously that means 85% confidence is what we're using there. Now, I'll draw a quick example here, what's going on. And basically, we have 0.85 in the middle, leaving 15% overall left over, which puts 0.075 in each of the two tails. If you remember the diagram that we showed on the previous slide, the z star value exists here. So we want everything to the left of that. So I'm looking for, on the table, 0.925, because that is the 0.85 plus the 0.075. And I'm going to go over and up to find the z star that corresponds to that. And I have my table right here, so I'm looking for 0.925. Clearly, I'm going to be on the positive side. And 0.925, let's see where the closest one is. The closest one exists at 1.44. So the z star for that one would be 1.44. I didn't write this in here, but the tail area is 0.075. And at this point, you might want to take a pause on the video and try to find the other ones on your own. Okay, I'll go through them a little bit quicker here for you. For number 2, the C confidence level is 0.9. That gives you 0.05 left over in each tail. So that means I'm looking for 0.95 in the middle of the Z table and going over and up. And 0.95, the closest value. Well, in this particular case, 1.64 and 1.65 are equally far away. I'll just choose 1.64. If you were to choose to use the inverse norm on your calculator, you would actually get a more exact value of 1.645. This is a fairly common one that you'll get to know pretty well as we move forward. Going into C equals 95% or 0.95, well, this is a 95% confidence interval, giving you 2.5% left over in each tail. And when I go into the Z table there, I have 1.96 as my Z star, and that might confuse you a little bit because yesterday in class we were working with the 95% confidence interval and we were saying that the critical value there was 2. That was an estimate that was coming from the 68, 95, 99.7 rule. And now we're just being a little bit more specific, and we're getting a Z star of 1.96, which is, pretty close. All right. If we wanted to be really, really specific, and we wanted to make sure that we were very confident we were containing the true mean, we might use a C, a confidence level of 0.99. That gives us a tail area of 0.005. So we're going into the table, and we're looking for 0.995. And when I go to 0.995, let's see. Again, I have one that are equally far away, and that is 2.57 and 2.58. And if I were to go into using inverse norm, I'd actually find that it's 2.575 as my z star, as my critical value there. So this is how we find the z star value. As we go further into these and do a lot more examples, you'll find that you'll just start to kind of memorize the common ones. And as I said before, the common ones are 95%, 90%, 99% is somewhat common if you needed to be really, really specific there. But you can find any one if you understand how the normal curve works and how the z-table works. All right? And this note down here at the bottom just kind of reminds us what we just said before, that we said that z star was 2 yesterday, and now we're saying it's 1.96. For the remainder of these processes, let's go ahead and use 1.96 just to be a little bit more accurate. All right? This gives you a visual understanding of what's going on. Again, here is your C, your confidence level. That's the central probability. And whatever that is, if that's, say, 90%, then to find the area left over in each tail, you take 1 minus C, so that's 1 minus 0.9 would be 0.1 over 2, and that would give you 0.05 left over here. And again, focusing on the z star being right here, you're looking for in the table 0.95 because that encapsulates the central probability plus the left tail. And then you go over and up to find the confidence level. All right. So just to get back to what the general form looks like again. And again, this is when sigma is known, meaning when we know the population standard deviation. The problem will change slightly when sigma is unknown, but we'll get into that in a later chapter. So we start with our estimate, which may be x bar or p hat. In this case, we're focusing on the x bars. And then the margin of error. The margin of error is broken down into the critical value times the standard deviation. And then we can say that there is here's the general form, excuse me. So here, when we're doing a confidence interval for means, I can spell. When we're doing confidence intervals for means, with sigma being known, this is what the form takes. X bar plus or minus z star times sigma over square root of n. Now, this four-step process here, this is what we're going to focus on for the rest of the chapter. We introduced what the conditions were today, but we're going to go ahead and do the whole process. I'm just going to intro it now in our notes, and then when we get to class tomorrow, we're going to go through the actual example. The very first thing we do, and we go ahead and number it just to keep ourselves organized, step 1, you state your parameter, which means you identify the population of interest and the parameter you want to draw conclusions about. So basically we say we are trying to estimate the true mean blank of blank, or from blank, okay? That tells us what the variable of interest is and what the population is that we're drawing this sample from. Then we check our conditions. We have to state whether it is or is not an SRS. We have to state whether the independence condition is met, and we have to state whether normality is or is not met. And again, if it's not one of those two things, meaning the central limit theorem or the population is normal, then we have to do some other processes, which we'll talk about in class tomorrow. Then step 3 is actually running the calculations, finding the estimate plus or minus the margin of error, which again is z star times the standard deviation of the sample. Okay? And then finally we interpret, which is that sentence. We are blank % confident that the true mean blank is between blank and blank. If you can remember that sentence, then you can go ahead and be comfortable with any of these problems here. So this 4-step process is sometimes referred to as the inference toolbox. It's really just the formal way of going through inference. And that's all I'm going to do for the video today. Make sure you understand all of these concepts, because in class tomorrow we're going to go through our first example in the formal 4-step process. And that's it for now.